Hi class, welcome to lesson 8. In this lesson, we will differentiate between elements, compounds, and mixtures. These are the three major classes of matter. We will identify an element by formula and particle diagram. And you will list the 7 diatomic elements. And finally, by the end of this video, you should be able to classify an element as a metal, nonmetal, or metalloid using either its physical properties or its location on the periodic table of elements. Let's get started. Recall that matter is what we're studying in chemistry. Chemistry is the study of matter. Matter is anything that has mass and takes up space or has volume. All matter is made up of atoms. Now, what's not matter? Energy is not matter. So heat, sound, light, those do not have mass. They do not take up space. So those are not matter. But all things that are made of atoms are matter. So we're going to use a flow chart. You can find this flow chart in your guided notes if you'd like to go and fill it in. We're going to use the same flow chart over the next 3 lessons. In this lesson, we're going to focus on the pure substance side of the flow chart. So whenever you have something that has mass and takes up space, it will be made of atoms. If you ask yourself, can it be physically separated? That means, can you pick apart the pieces without making or breaking any bonds? Then, if the answer is no, you cannot pick it apart, then you have a pure substance. So today we're going to focus on a pure substance. And pure substances fall into one of 2 categories. So if you have a pure substance, something that cannot be physically separated, the next question to ask yourself is, can it be chemically separated? Can you break bonds to pull it apart into simpler pieces? If the answer is no, then you have an element. And if the answer is yes, you have a compound. So today we're going to focus on elements. Now, all pure substances have a definite composition and unique properties. In later lessons, we'll focus on mixtures, which can be separated and are described as homogeneous or heterogeneous mixtures, but more on those later. Again, we're going to focus on the left side of the table, particularly elements today. Just to give you an idea of what an element is, here we have some particle diagrams that help us see that both elements and compounds have definite composition and a constant composition. Now, elements cannot be broken down into any simpler elements or any simpler types of atoms. So they are made up of the same atoms. Sometimes they can be made up of multiple atoms that are bonded together, but still there's only one kind of atom in the formula. All element symbols have one capital letter, and they may have no lowercase letters or one lowercase letter or even 2 lowercase letters, but there'll only be one capital letter. If you have more than one capital letter in a formula, you know you're not looking at an element. But just like elements, compounds also have, each piece has exactly the same composition. Both elements and compounds are pure substances, and all pure substances have definite and constant composition. So when we look at the elements here we have helium. When we have helium over here, notice that every particle is identical. And here we have another element. This is the element nitrogen. And again, although there are 2 particles stuck together, each piece is identical. So this is a pure substance. and we'll see why it's an element. And then again, here we have another element. This is O3 called ozone. So our ozone layer is made out of this, and each piece has these 3 red oxygen atoms bonded. Now, compounds also have definite and constant composition. So in this first example here, we have 2 H's and 2 O's, 2 hydrogens and 2 oxygens. So this is called hydrogen peroxide. And every piece is absolutely identical. Same thing with this compound here. In this compound of sodium chloride, what we can see is that each piece has 1 red atom and 1 blue atom. And finally, again, here in this compound of hydrochloric acid, we have 1 hydrogen atom and 1 chlorine atom in each sample. So each piece is absolutely identical. We want to contrast that to mixtures. Now, mixtures are not pure substances, so they do not have a constant composition or a definite composition. So notice that the pieces are not identical. So here we have this white colored particle, and here we have this red colored particle. So these pieces are different. And again, over here we have a compound that kind of looks like a Mickey Mouse. It looks like it has a red head and white ears. And then we have an element that's a red atom here, but each piece is not identical in this mixture. Again, today we're going to focus primarily on the elements. Here are some examples of elements. Notice that elements are pure substances because each piece in the particle diagram is identical. Elements all have unique physical and chemical properties, and their physical properties allow us to classify them as metals, nonmetals, and metalloids. So by now, you should be able to differentiate an element from a compound and a mixture, and you should be able to identify an element by its formula and particle diagram. There are 2 major types of elements. There are monoatomic elements, the prefix mono meaning 1, atomic meaning atom. So these elements have atoms that are not bonded together at all. Sodium is a good example. What you can see in this particle diagram to your right are that we have these individual sodium atoms and they're not bonded to anything. Now, diatomic elements, di means 2 atoms. These elements have 2 of the exact same types of elements bonded together. So hydrogen gas, that explosive gas, is a really good example. So when we look at the particle diagram, notice how each particle actually has 2 hydrogen atoms. They're bonded together. Now, it's still a pure substance because each particle, again, that doublet of hydrogen, is identical. Now, you will have to memorize the 7 diatomic elements, and you can do that one of 2 ways. I have been using a mnemonic device for a really long time, so I'll share that one with you. That mnemonic device is I brought clothes home from Old Navy. So using this mnemonic device, notice how when I wrote the element symbol, it is always followed by a subscript, a little small 2, which indicates that there are 2 elements present there bonded together. So this is the mnemonic device I've always used. Now, some other people prefer something called the Magic 7. To employ the Magic 7, you have to look at your periodic table and start on element number 7, nitrogen. And you're going to make a 7. So N, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So you can see there's a 7 here, but the problem is there's only 6 boxes. So fun thing, in chemistry, we have a lot of rules, and every rule gets one exception. So if you use the magic 7, you're going to have to add the hydrogen over here into that. So if you prefer that way, go ahead, just don't forget the hydrogen. And it's also called the magic 7 because not only do we have the number 7, but there are 7 diatomic elements. So here's to get another picture of the magic 7 if it helps you memorize the 7 diatomic elements. You choose the way that works best for you. So by now, you should be able to list the 7 diatomic elements. Make sure you start practicing this now, as it will be on a quiz in the near future. So in the final part of this lesson, we are going to need to classify elements as metals, nonmetals, and metalloids. From this picture, you can see that their general location on the periodic table kind of clumps the elements together. So we have the metals tend to lie on the left side of the table, and most of the elements are indeed metallic. Now, we have the nonmetals over here on the right side of the table, and the metalloids fall in the middle here. Now, we can use physical properties that we observe with our 5 senses to determine if something is a metal or a nonmetal. So if you were in the cafeteria and you found a metal spoon and a plastic spoon, I know that just based on your physical observation without doing any chemical reactions, you will likely be able to tell which spoon is a metal and which spoon is a nonmetal. So here you can see that the metals, which again, they were over here on this side of the table, they tend to have similar chemical properties. A lot of them appear to be gray solids versus the nonmetals, which are over here on the right, are much more colorful. They're also varied. So here we've got some gases and we have some solids over here in the nonmetal region of the periodic table. So metals have some unique physical properties that you need to be familiar with. So metals tend to be gray and shiny. In chemistry, we often use the word lustrous, or they have luster when they're shiny. So they're gray, they have luster. Many of them are solids at room temperature. They're malleable, which means they're bendable and they won't break. You can even hammer them into a sheet. They're ductile, meaning you can pull them into wires. And they tend to be good conductors of both heat and electricity. Metals also have relatively high melting points and boiling points. So you don't really worry about metals melting, let's say, in your pocket. Now, chemically, metals are unique because they tend to lose their valence electrons in order to become more stable. And when an element loses its valence electrons, it is oxidized, or it undergoes oxidation in a chemical reaction. Now, nonmetals, they have kind of the reverse of metallic properties. So nonmetals tend to come in a wide variety of colors and states of matter. They have lower melting points and boiling points compared to metals, and they tend to be brittle, which means they kind of crumble and fall apart, and they're poor conductors of heat and electricity. Nonmetals tend to gain valence electrons or undergo a process called reduction. Now, we say that nonmetals are reduced because if you gain a negatively charged electron, then your charge goes down in a chemical reaction. And finally, we have metalloids. Metalloids are kind of in the middle, and they, depending on your circumstances, they have properties of both metals and nonmetals. That's pretty much all you have to know about metalloids, is they have properties of both, and you have to be able to identify them based on their location on the periodic table. So let's look at the periodic table. So looking at the periodic table, the thing that will help you the most in distinguishing between metals, nonmetals, and metalloids is this bold colored staircase right here. So when we have this bold colored staircase, we know that the metals tend to be over here on this side of the staircase, on the left side or under the stairs. And the nonmetals tend to be on the right side of the staircase. If you forget whether or not the metals are on the left or the right, just find an element that you are sure is a metal. Like most people know that iron's a metal, or nickel, or copper. We also have silver and gold. Now, if you're not sure of the element symbol, all the element names are on the next page of your reference table, table S. So find something that you know is a metal, and then you'll know that all of the elements around it are also metals. Same is true for nonmetals. So the nonmetals are here on the right of this bold staircase. Most people know that oxygen is a nonmetal. So then all of the elements around oxygen should be nonmetals as well. Now there's one tricky part about nonmetals. Most of the nonmetals are here on the right of the periodic table, but there is one straggler. Again, every rule in chemistry has an exception. So hydrogen, which is located close to all the metals, is not a metal. Hydrogen is a nonmetal. So we'll want to make sure that we always classify hydrogen, an explosive gas, as a nonmetal and never as a metal. For the metalloids, we're going to use the bold colored staircase. If an element touches the bold colored staircase on two sides, then it is a metalloid. Of course, there's always one exception. So what we can see is that silicone is a metalloid because it touches on two sides. But the exception is here. It's aluminum. Aluminum does touch on two sides, but it is not a metalloid. Hopefully, you already know that aluminum is indeed a metal. Think about its physical properties. Aluminum is shiny or lustrous. It is gray in color, and it's very bendable. So aluminum is a metal. All of the other elements that touch on two sides are considered metalloids. Now, make sure the element touches on two sides, because here we have gallium, but gallium only touches on a corner. It doesn't have two bold lines attached to it. So gallium is not a metalloid, but instead gallium is a metal because it lies on the left side of the periodic table. So by now, you should be able to classify an element as a metal, nonmetal, or metalloid using its physical properties or its location on the periodic table. This concludes lesson number 8. Make sure you've taken good notes. Write down any questions you have and bring them to class. We will discuss them. Complete your homework on Google Classroom and put your reference table and calculator back in your backpack so you will be prepared for class. I'll see you soon.